This tutorial will describe how to work with data functions that translate between DNA or RNA and protein sequences in Lead Discovery ChemCharts. The translate DNA to protein data function does exactly what its name suggests: translation of coding DNA or mRNA sequences to protein sequences. In this table is a column containing coding DNA sequences. These sequences are equivalent to the expected mRNA sequences with thymine rather than uracil, but either form will work. Clicking on Translate DNA to Protein script will open the data function's input dialog. Select the table and the column containing the sequences of interest. Different codon definition tables are available, and descriptions of the various tables can be found through the NCBI website. A link is provided in the description. Choose a method to define the translation initiation site. The three options available are to define the first three nucleotides of the sequence as the first codon, to start at the first ATG in the sequence and use that to define the reading frame, or to start at the first initiation sequence defined in the selected codon table. Once the data function is complete, the results pane provides a list of options used for this data function. In the table, a new column is created that contains the translated protein sequence. Stop sites are illustrated with an asterisk, and translation continues at the codon following the stop site. In addition to translating from coding DNA or mRNA to protein sequences, the translate sequence bidirectional data function provides a way to convert from protein sequences back to coding DNA sequence. Select the table and the column with nucleotide or protein sequences and choose a codon table. The data function will automatically detect the type of sequence and translate or back-translate appropriately. When the data function finishes, the results pane provides the selected options, and a new column is created with the back-translated coding DNA sequence. The back-translated coding DNA sequence uses a preferred codon for each amino acid based on the chosen codon table. As a result, the newly generated coding DNA sequence will likely not match the original coding DNA sequence exactly. The translate sequences from all open reading frames data function also does what its name suggests. For the three possible reading frames in both the positive and the negative strand directions, the nucleotide sequence will be translated to a protein sequence. Select the table and the column with nucleotide sequences, and optionally choose a column that provides a unique sequence ID. The minimum protein length value will limit the output to only those protein products meeting this length requirement. Finally, choose a codon table. Once the data function finishes, the Results tab will show the options used for the data function. To view the output table, click on the Configure Visuals icon. Depending on the nucleotide sequences and the minimum protein length settings, there may be no results, one or multiple results for each of the original nucleotide sequences. When a translated protein sequence meeting the minimum length is produced, the row number of the sequence is provided, along with the sequence ID if an ID column was selected. The protein sequence is illustrated, along with its amino acid length. The strand that produced this protein product is noted as a plus or a minus, as well as the reading frame as a 1, 2, or 3. The starting and ending positions of the original sequence corresponding to this protein product are also listed. Thank you for watching, and check out the other Lead Discovery ChemCharts tutorials.